So today we're going to be looking at factors, and we're going to start with, actually I think maybe 12 is a bit too hard to start with, isn't it? We'll come on to 12, but let's look at an easier number first. Let's look at 3, and we will come back to 12 afterwards. So when we're talking about factors, we want the whole numbers that go exactly into a number. So 3, we know that it's divisible by 1 and divisible by 3, because 1 times 3 is 3. The only other possible number that's smaller than 3 is 2, and that doesn't go in, does it? So because 2 times 1.5 will be 3, and we're only looking at whole number combinations. So these are natural numbers, whole numbers, and we can visualize what this means by looking at this rectangle. It's a 1 by 3 rectangle. So the height of the rectangle is 1 and the width is 3. So it's a visual representation of 1 times 3 being 3. So next let's look at one just a bit more difficult. So we're going to look at the factors of 8. So again, 1 goes into 8, and 8's an even number, so 2 goes into 8. 3 doesn't go in, does it? Because 3 would go into 6 and 9, so no, 3 doesn't go into 8, but 4 does. In fact, 2 4s are 8. And 5 doesn't go in, 6 doesn't, 7 doesn't, and 8 does. Now actually, the way I was just thinking about that wasn't the most efficient way of doing it. Much better to always start with the number 1 and the number itself. So earlier on we had the number 1 going with the number 3. So this time we would start with 1 and then write down the 8, because 1 times 8 is 8. And then think about, does 2 go in? Yes, 2 goes in because 8 is even, and 2 goes in 4 times. Then we'd think, does 3 go in? And it doesn't. And then we know we've finished, because if nothing between 1 and 2 goes into 8, then nothing between 4 and 8 will go into 8, because you'd have to have the number between 1 and 2 multiplying the number between 4 and 8, and there isn't a whole number between 1 and 2, so that just isn't going to work. So we know we've got all the factors. And again, we could have a look at how we could represent these two possible rectangles. So here you can see that the two rectangles represent the second way of thinking about finding the factors, so that the first rectangle measures 1 by 8 and the second one is 2 by 4. So those are the only two ways of taking 8 squares and arranging them in a rectangle. And that shows that the factors of 8 are 1, 2, 4 and 8. So 1 times 8 is 8 and 2 times 4 is 8, and no other combinations of whole numbers will give you 8. So before we go back to 12, let's look at 9 next. So if we use the method of starting with 1 and the number itself, so we've got 1 and 9, then we think about 2. Well, 2 doesn't go into 9 because 9's an odd number. And then we think about 3. Now 3 does go into 9, doesn't it? How many times? It's 3, isn't it? So we don't write down the 3 twice, because we just want to list what the factors of 9 are. And when we've got to that point, when we know that a number times itself gives us the number we're looking at, then we know we've finished, because we would find that any number bigger than 3, between 3 and 9, would have to be multiplied by a number between 1 and 2 to give us 9. And that's not possible, because 2 doesn't go into 9. So this time we're multiplying 1 and 9 together, and the 3 is all on its own. It's multiplying itself. So this happens when you've got what we call a square number. And we'll see when we draw one of the rectangles that it turns out to be a square. So let's have a look. Right, so then you can see that we have got a rectangle measuring 1 by 9 and then a square 3 by 3. So the factors of 9 are 1, 3 and 9. So given that we've got 3 times 3 is 9, obviously we go square in this case. Right, so now let's go on and look at 12. So we're going to start with 1, and we don't know how many factors there are between 1 and 12, so we're going to leave a really big space. It might be too long. Let's see. So 12 is divisible by 2. So we have 2, and then at the other end we are going to write, what's half of 12? 6. So we know that because no numbers between 1 and 2 go into 12, that nothing between 6 and 12 will go into 12. Then we try 3. 3 does go into 12 4 times. So we put that there. And you can see I've actually left a gap that's far too big because we've obviously finished now, because 3 is followed by 4, isn't it? So we have only 3 pairs of factors giving us 12. 1 times 12, 2 times 6, and 3 times 4. And let's have a look at the relevant rectangles. So you can see that we've got a 1 by 12 rectangle, 2 by 6, and one that's 3 by 4. By the way, it doesn't matter which way up I draw these rectangles, so I could have had a long vertical rectangle, so 12 squares going up and down the page and 1 across, 6 going up and down, 2 across, and similarly for the 4 by 3. It's just that given the page I'm working on, it was just neater to draw them this way round. And of course they could have been drawn in any way you like, diagonally if you like. But hopefully you can see how that looking at these rectangles helps you see what we're doing when we're finding factors. The next one we're going to do is going to be a bit bigger, so I'll leave the drawing of the rectangles to you. You might want to maybe try it on graph paper with smaller squares. So we are going to look at 100 next. Right, so again we're going to have a really long gap between the two numbers. Let's make sure we're on the same line. Is that the right one? Yeah, I think it is. And put a comma there. So we know that 1 times 100 is 100. Let's see if I can fit all these numbers in. Right, so 100 is even, so we are going to have 2, so we halve 100 and get 50. So 2 50s are 100. So nothing between 50 and 100 goes into 100. 3 doesn't go into 100, does it? 4 does though. And one way of thinking of this is that I have doubled 2, so I'm halving 50. So 4 times 25 goes in. 5 goes in, doesn't it? It does. 5 times 20. 6, 7, 8, 4 goes in 25 times. If we halve 25, we get 12 and a half. So no, 8 doesn't go in. 9 doesn't go in, but 10 does go in. And 10 tens are 100, so another square one. So that's in the middle on its own. If you want to, you can join these up. So 5 times 20, 4 times 25. Notice that these lines never cross each other. 2 times 50 and 1 times 100. When you've done this for a while, you can just kind of imagine these lines, but it's handy when you're first doing it to get the idea of it, and by putting the kind of dot in the middle when it's a square number. So maybe you'd like to try some of these for yourself. For example, what are the factors of 97? What are the factors of 36?